Hi, my name is Andrea Grenga, and I'm going to talk today about vocabulary load in scientific figures within introductory geology textbooks and what that might mean for textbook design. So textbooks are universally used in introductory geology classrooms, and previous research has found that there's a large number of terms in textbook glossaries. And that's significant because new learners have limits to the amount of information that they can process in their working memory, so too many terms may overload them and interfere with moving info into long-term storage. So we know that there's a large number of terms in glossaries, but we don't know is the vocabulary load within the actual text, which most students will focus on. So in this study, we attempted to answer several questions. So the first overall question was, what is the vocabulary load of introductory geology textbooks? And the second was if there are any differences between text and figures within the books themselves. So in terms of our method, we chose sample geology textbooks that are commonly used in the United States, and we counted the total number of words both within the text and in the figures. For text, we counted words in the headings in the paragraphs, and in figures we included words in the titles, the captions, and the pictures themselves. So what did we find? So to answer our first question for overall vocabulary load, both in figures and text, we found that nearly 1 in 3 words are geologic. We also found that there are different types of vocabulary words. So the majority, about 77%, are glossary words, where about 17% are common words that we use every day but have specific geological meaning. So why is this important? One is that having a large number of terms may put the focus on memorization versus processing, and it may also overload cognitive capacity and cognitive systems, so it will be hard to remember and process them more deeply. The second reason, especially with these common words right here, is that previous research found that students are less likely to identify them, and because they have dual meanings, this could potentially lead to misconceptions. So to answer the second question, which was comparing vocabulary load within the text versus figures, we found that figures have a greater proportion of geologic terms, with about 43% of words in figures being geologic and only 28% in the text. And also within figures there's a greater proportion of distinct words as compared to text. So this is important for a couple of reasons. One is that cognitive science has found that information is processed into 2 different channels, both pictorial and verbal, and having a large number of words could potentially impact the verbal channel. The advantage of figures is that it uses both, but if we have too many words, it negates that advantage. The other, with respect to the distinct words, is that we sampled only a few pages of text, so if we were to look at the whole textbook, we may find hundreds of more words, further impacting the cognitive and vocabulary load. So in terms of limitations for this study, the textbook samples might not have been representative of the entire text. Also, when we counted the number of words, we focused on words versus terms. And we looked at the words that are in the textbook. So in everyday life, students may have exposures to word over time, which thus impact and reduce cognitive load. Nevertheless, despite these limitations, this study has important implications for textbook design. The first would be to experimentally test vocabulary load, both in figures and in paragraphs. And the second is to pay attention to how vocabulary is used. So for example, to introduce words gradually over time so students have practice learning them before they go on to learning larger concepts that require understanding of the words. So despite a lot of potential problems with vocabulary load, particularly in figures, there are potential solutions for reducing that load and enhancing learning.